The first image ever taken from the surface of another planet was not captured by a human, nor by a modern artificial intelligence system. It was captured by a dying machine, alone, crushed beneath an alien sky, slowly being cooked alive in a world hotter than any natural oven ever created on Earth. That machine had only minutes to live. Every second, its internal temperature rose closer to destruction. Every component inside, it was fighting a losing battle against physics, and yet, before it died, it opened its mechanical eye and showed humanity, something no human had ever seen before. It showed the surface of Venus. For centuries, Venus had been a symbol of beauty. It shone brightly in the night sky, earning names like the morning, star in the evening. Star, it was Earth's twin in size, Earth's neighbor in space, and for many scientists, it was believed to be Earth's twin in environment. In the early 20th century, astronomers imagined vast oceans beneath its clouds. They imagined warm tropical swamps, endless rain, and perhaps even alien forests. Some believed Venus was younger than Earth, still forming, still evolving into a paradise. But all of those dreams were wrong. Venus was not a paradise, it was a death trap. It was a furnace, it was a pressure chamber, it was a world where no human could ever survive. And yet, the engineers of the Soviet Union refused to accept that such a world could remain unseen. They believed that even hell itself could be explored, and so they began one of the most dangerous and ambitious space missions in human history. Their mission was simple in theory, but nearly impossible in reality. They would land on Venus. They would see its surface. They would show humanity the truth. In the beginning, scientists did not know how dangerous Venus truly was. The planet was hidden beneath thick clouds that reflected sunlight, making direct observation impossible. Telescopes showed nothing but endless brightness. This mystery allowed imagination to dominate science. Some scientists believed Venus had oceans because clouds on Earth were associated with water. They believed thick clouds meant rain. They believed rain meant oceans. They believed oceans meant life. This belief shaped early mission designs. The first probes sent toward Venus were built with optimism, not fear. Engineers assumed high temperatures, but not extreme ones. They assumed pressure, but not crushing force. They believed their machines would survive landing. But Venus revealed its truth slowly and brutally. As the first probes entered the atmosphere, the signals began to fade, then they stopped completely. The probes had not landed, they had been destroyed. The atmosphere itself had crushed them. The pressure near the surface was 90 times greater than Earth's surface pressure. This was equivalent to being nearly 1 kilometer beneath Earth's oceans, where even the strongest submarines struggled to survive. The probes collapsed under this force. Their metal shells bent inward. Their electronics were destroyed instantly. Their mission ended before it truly began. These failures shocked scientists. They forced humanity to accept a terrifying truth. Venus was not Earth's twin. It was Earth's opposite. It was a warning. It was a vision of what happens when a planet loses control of its climate, when heat becomes trapped, when temperatures rise beyond control. This realization transformed the mission. The goal was no longer simple exploration. It became survival. Engineers now faced the challenge of building machines capable of surviving the most hostile environment ever encountered. The solution required abandoning traditional spacecraft design. Engineers realized that flat surfaces and thin walls would collapse under Venusian pressure. They needed a structure capable of resisting crushing force from all directions equally. The answer was the sphere. Spheres distribute pressure evenly, making them incredibly strong. This design principle is used in submarines that explore Earth's deepest oceans. The Soviet engineers applied the same concept to space exploration. They built landers shaped like spheres. They forged them from titanium, a metal known for its strength and resistance to heat. These spherical shells were thick, heavy, and incredibly durable. They were not elegant. They were not lightweight, but they were strong. They were designed to survive where all previous machines had failed. The titanium shells became armored prisons, protecting fragile electronics inside. This design transformed the probes into planetary submarines, diving not into water, but into atmosphere. The analogy was perfect. Venus's atmosphere behaved like an ocean, with immense pressure crushing anything that descended too deep. These landers were built to dive into that ocean and survive. The cost was enormous. The added weight required more powerful rockets. It required precise launch timing. It required flawless engineering. But the engineers accepted this cost. They knew survival was more important than efficiency. They were no longer building explorers. They were building survivors. These machines represented human determination. They represented humanity's refusal to remain blind. They represented the belief that knowledge was worth any cost, even if the machine collecting that knowledge would never return. Pressure was only one enemy. The greater enemy was heat. Venus had a surface temperature of approximately 475 degrees Celsius. This temperature was hot enough to melt lead. It was hot enough to destroy electronics instantly. It was hot enough to erase any unprotected machine. Engineers faced an impossible challenge. How do you protect electronics from temperatures that exceed their destruction point? Their answer was ingenious. Before entering Venus's atmosphere, the landers were cooled to -10 degrees Celsius. This supercooling created a temperature buffer. It delayed the inevitable heating that would occur after landing, but cooling alone was not enough. The landers also contained special chemicals known as phase change materials. These materials absorbed heat by changing from solid to liquid. This process consumed thermal energy, slowing the rise of temperature inside the lander. One of the materials used was lithium nitrate. This substance acted like a thermal sponge, absorbing heat and protecting the electronics. This design gave the landers limited operational life. They could survive only 30 to 60 minutes after landing, but those minutes were enough. Those minutes allowed them to transmit data. Those minutes allowed them to capture images. Those minutes allowed them to complete their mission. The landers were not designed to survive forever. They were designed to survive long enough to tell their story. They were designed to speak before dying. Capturing images on Venus required solving another impossible problem. Standard cameras could not survive the pressure. Their lenses would crack. Their housings would collapse. Engineers needed a completely new imaging system. They created mechanical scanning devices called telephotometers. These devices did not capture images instantly. Instead, they scanned the environment. Line by line, they looked through tiny quartz windows. Quartz was chosen because it could withstand extreme pressure without breaking. The telephotometer converted visual information into electronic signals. These signals were transmitted slowly to orbiting spacecraft. The orbiters then relayed the signals back to Earth. The images were reconstructed piece by piece. This process was slow, but reliable. It allowed humanity to see another planet's surface for the first time. The images were not perfect. They were grainy. They were incomplete, but they were real. They were proof that humanity had reached another world and survived long enough to see it. This achievement was not just technological. It was philosophical. It proved that no place in the solar system was beyond reach. It proved that even the most hostile environments could be explored with intelligence, determination, and courage. When the first successful landers touched the surface, they revealed something unexpected. Scientists had predicted darkness. They believed thick clouds would block sunlight, but the surface was not dark. It was illuminated by diffuse light. The thick atmosphere scattered sunlight, creating a dim but visible environment. The ground was covered with rocks. These rocks were sharp and angular. This indicated minimal wind erosion on Earth. Wind smooths rocks over time. On Venus, the dense atmosphere prevented strong surface winds. This preserved the rocks in their original shapes. The landscape appeared dry, barren, and lifeless. There were no oceans. There were no plants. There was only stone and heat. This discovery shattered centuries of imagination. Venus was not a jungle. It was a desert. Burning desert locked beneath endless clouds. This revelation changed planetary science forever. It showed how dramatically planets could evolve. It showed how similar beginnings could lead to radically different outcomes. The greatest breakthrough came when later landers transmitted color images. These images revealed a world bathed in orange light. The thick atmosphere filtered out blue wavelengths, leaving only red and orange colors. This gave the surface an alien appearance. The sky was not blue, it was orange. The ground was not familiar, it was foreign. These images transformed Venus from an abstract concept into a real place. They allowed humans to visualize another world in color. They made Venus real in a way it had never been before. The landers also carried microphones. These microphones recorded sound for the first time on another planet. They captured faint wind noise. They captured mechanical vibrations. This was the first time humanity heard the sound of another world. It was a historic moment. It transformed Venus from silent mystery into audible reality. Not every part of the mission went perfectly. In one famous incident, a lander's soil analysis arm accidentally tested its own lens cap. The cap had been ejected earlier, but landed beneath the arm. When the arm extended, it pressed against the cap instead of the soil. This produced incorrect data. This mistake became one of the most famous accidents in space exploration. It demonstrated the unpredictability of planetary missions. It showed how small mechanical coincidences could affect scientific results. Yet even this mistake provided valuable lessons. It showed engineers how to improve future designs. It showed the importance of redundancy in testing. It showed that exploration was never perfect, but always valuable. Decades later, scientist Leonid Xanfomality re-examined old images. He claimed to see objects that appeared to move. This sparked speculation about life on Venus. Some believed these objects were living organisms. Others believed they were mechanical debris. The scientific community remained skeptical. The extreme heat and pressure made life unlikely. Most scientists concluded the objects were parts of the lander or optical artifacts. But the controversy reminded humanity that Venus still held mysteries. It reminded humanity that exploration was not finished. It reminded humanity that unanswered questions remained. Since those missions, no spacecraft has successfully returned images from Venus's surface. Other missions have orbited the planet. They have mapped its surface using radar. They have studied its atmosphere, but no lander has survived long enough to send new images. The photographs taken by Soviet landers remain humanity's only direct visual connection to Venus. These images are frozen moments in time. They show a world unchanged for decades. They show machines that sacrifice themselves for knowledge. They show humanity's courage in the face of impossible odds. Today, the remains of those landers still sit on Venus. They are silent. They are dead. But their mission lives on. They proved that even the most hostile world could be seen. They proved that humanity's desire to explore is stronger than fear. They proved that even in hell, it is possible to open your eyes and see.